we're back with another episode of the Utility Strategy Podcast, the show where we bring to you industry experts who share their challenges and how they overcome them in the subsurface utility space. Today we have two very special guests who have never been on the show before. The first is Lindsay Kelley, 4M's VP of Marketing. Lindsay, how are you doing?
I'm doing great, David. How are you?
And the second is someone who you've probably heard of recently a lot, and that is Chat GPT. And what we're going to be doing today is test Chat GPT and try and figure out how knowledgeable or how well does it know the subsurface utility space and its challenges. But first, Lindsay, tell us a bit about yourself.
Well, David, I've recently joined 4M Analytics. It's been about 2 months now. Really excited to be here. Such an amazing product, platform, software, database. It's so many things rolled into one easy-to-use platform. I've spent a lot of time in marketing in my career. I most recently came from Trimble, and I actually worked with our VP of Sales, current VP of Sales at 4M Analytics, Joe Eberly, while I was there. So I'm really excited today to play the part of the, I guess you could say, translator for Chat GPT, because my role today is to input your questions into Chat GPT and read you the answers that it provides.
So let's get into it. The first question that we have for what's going to be our nickname for Chat GPT? It just seems too long for the Chat GPT. Yeah.
Let's call her Kathy.
Okay,
like Chatty Kathy.
Okay, so Kathy. So our first question for Kathy today is: what is the most catastrophic utility strike that you know of, and why? Why did it happen?
Really great question. So right now she is generating her, we're calling her Kathy, so she can be a she. She has a very lengthy response here. So I'm just going to start by prefacing that. It may take a little while to get through, but one of the most catastrophic utility strikes in recent history is the gas explosion that occurred in San Bruno, California on September 9th, 2010. The explosion resulted in the death of 8 people, the injury of 66 others, and destruction of 38 homes. The cause of the explosion was determined to be a ruptured natural gas pipeline owned and operated by Pacific Gas and Electric, PG&E, which had been improperly installed in the 1950s. The pipeline was buried under a residential area and had not been properly maintained or inspected over the years. The explosion occurred when the pipeline ruptured and ignited, sending a massive fireball into the air. The incident prompted investigations by the National Transportation Safety Board and the California Public Utilities Commission, which found that PG&E had a history of safety violations and inadequate record-keeping practices. The company was fined over $1 billion for its role in the explosion and was forced to implement numerous safety improvements and pipeline replacements. The San Bruno gas explosion was a tragic reminder of the importance of proper maintenance and safety protocols in utility infrastructure. It also highlighted the need for stricter regulation and oversight of utility companies to ensure the safety of the communities they serve.
I'm reading here that eventually they ended up paying $5 million to resolve the suits over the blast that was caused. Wow, that's crazy. But to give PG&E some credit, that in the past, I'd say decade, we're seeing a lot of investment on their side in protecting their utilities. So they had a lot of fines and not marking their utilities correctly, and they put a lot of effort into that. And also, I think about a year ago, with all the fires that happened in the wildfires that happened in California, so they're now leading a major investment in undergrounding which is not gas, but mainly for electric, but is there's a good chance that that will help us prevent a lot of the potential natural disasters that can happen from having these overhead exposed electric utilities. The challenge for them is going to be, though, seeing what's happening beneath the surface, because there's a lot of mileage that needs to be put into the ground. And I think the CEO, she came out and said that for a long time it wasn't the ROI of burying the electric lines was negative, so they didn't do it. But now it's kind of the first time in history where it makes sense to create resilience for the network, to actually bury the lines and start undergrounding them, which is I think the term in the industry. So yeah, so just, not everything
Yeah.
is bad with PG&E.
Right. No, and they've obviously taken great measures to correct that. And one of the things that immediately came to my mind, and I think will probably come to the minds of lots of other folks listening, is the movie Aaron Brockovich. And I'm not sure if you've ever seen it, but Aaron was a whistleblower back in 1993 in the town of Hinkley, California. Folks were getting really sick from the drinking water, and it was contaminated due to the negligence of PG&E. So definitely something that brought to light the issues that they had, and probably shed that light enough that it helped them to start to fix a lot of their issues and challenges.
So next question. And I think it's in the same context. What are the direct and indirect costs of utility strikes?
All right. So here's what Chatty Cathy has to say. Utility strikes can result in both direct and indirect costs. Direct costs include repair costs. This includes the cost of repairing or replacing the damaged utility lines or infrastructure, which can be quite expensive. Fines and penalties. Depending upon the location and severity of the damage, fines and penalties may be imposed on the party responsible for the utility strike. Emergency response costs. Utility strikes can sometimes cause emergencies that require immediate response from emergency services, which can also add to the direct costs. So here's what she says for some of the indirect costs. Delays and disruptions to projects. I think our audience will definitely resonate with that. Utility strikes can cause significant delays due to construction projects, which can result in additional labor costs, project management costs, and lost productivity. Also, damage to equipment and property. Utility strikes can damage equipment and property, which can result in repair or replacement costs. Lost revenue. Delays and disruptions to projects caused by utility strikes can also result in lost revenue, especially for businesses that depend on timely completion of projects. Really big sticking point these days with all the infrastructure funding and all the projects that have started. Safety risks and liability. Utility strikes can pose safety risks to workers and the public, which can result in liability issues and increased insurance cost. And last, reputation damage. Utility strikes can also damage the reputation of the party responsible, which can result in lost opportunities and damage to their brand. And I think with the previous question, PG&E right there, a lot of bad press for them with all their challenges. Definitely a reputation.
I think that there's in the late Jeff Zeiss, who was a guest on our podcast and part of the 4M company. So he posted on a 2020 blog sort of a range of what are the direct costs of utility strikes. And it's like the direct costs are not so significant, especially for GC, utility company, excavator, depending whose fault it here. But I think that the lowest here is for steam pipe would be $1,800. And the most expensive would be for a liquid pipeline, which would be about nearly $8,000. So average, we're at about 4K. So that's like for a multi-million-dollar project, which is like a small infrastructure project, it's not really significant. But the question is, what about the teams on the ground who are just kind of waiting around? What about the machinery that you brought on site that's not doing anything because you're waiting first to see, like, you need to fix a pipe, then you need to decide if you're going to relocate or not. So you need to have the designers who are starting to kind of work and figure out what are we going to do here. And if it's a small relocation, so fine, that's easy. But if there's a major design initiative that they need to put forward, so a major change order that they need to present to the owner, that's a big deal, and that can be easily a significant cost of the project. So.
Oh yeah, you just had a lot of heads nodding because I mean, just alone, some of the equipment that you need to rent by the day, the thousands of dollars, and the time lost if you don't know where you can dig with that massive piece of equipment. It's mind blowing.
And there's also I think one of the things that we're hearing a lot of people talk about today is the fact that GCs are always surprising the owners with more and more change orders. And the thing is, depending on the delivery method of the project, is that if the owner provided the utility data and the owner is liable for that change order, and it's a significant one, they're not happy. They're not happy at all because they don't have anyone to blame but themselves.
Yep. And I mean, there's some of the numbers that we would see just in the past from past lives that I would see. It's somewhere change orders can be responsible for up to 15 or more percent of the value of the contract.
Yeah.
It's just so much money in change orders.
Yeah.
It's I feel for the folks who have to go through that all the time. So. All right, what else can Chatty Cathy answer?
What is the history of subsurface utility engineering in the U.S.?
Sue. Yes. All right. So let's see. Chatty Cathy says, subsurface utility engineering, otherwise known as SUE, is a branch of civil engineering that deals with mapping and managing underground utility networks such as water, sewer, gas, and telecommunications. The history of SUE in the U.S. can be tracked back to the 1980s, when several high-profile incidents of underground utility damage led to the development of new technologies and methodologies to prevent such incidents. The first major incident that brought attention to the need for SUE was the Kansas City Hyatt Regency walkway collapse in 1981. The collapse killed 114 people and injured over 200 others. The investigation found that the collapse was caused by a design flaw, but also identified that the construction team had accidentally severed a major beam during excavation work because they were unaware of its location due to poor record keeping of the utility lines. This incident led to a renewed focus on the need for better mapping and management of underground utilities. In response to this need, several organizations, including the American Society of Civil Engineers, the Federal Highway Administration, began to develop new standards and guidelines for SUE. In 1990, the ASCE published the first set of SUE standards known as ASCE 38-02, which provided a framework for classifying the accuracy of subsurface utility information. 2 more paragraphs. She was very chatty in this one. So over the next few decades, SUE technologies continue to develop, including the use of ground-penetrating radar, electromagnetic induction, and other geophysical methods to locate and map underground utilities. In 2015, the ASCE published an updated version of the SUE standards known as ASCE 38-02, which included new guidelines for using these advanced technologies. Today, SUE has become an essential part of infrastructure design and construction projects in the U.S., with many state and local governments requiring SUE surveys before starting any excavation work. The use of SUE has helped to reduce the risk of underground utility damage and improve the efficiency of safety of construction projects.
Yeah, that was
that was a lot.
To unpack there. I'm not sure about the dates though. I think there's a chance that Chatty Cathy is a bit wrong there because we had Jim Ansbach on one of the episodes, and I think, if I'm not mistaken, the standard was released in around the 2000s, early 2000s, not 1990. That sounds a bit too early for me, but I don't know. We need to. I don't accurately recall, so we need to check with Jim. But something that I do that we are seeing is states taking more and more, paying more and more attention to the need for accurate utility data, and we can see it in Colorado with their legislation that that utility records must be held to a Sioux standard, and that before you start digging, you need to use Sioux data, which is mandated by law. There's challenges of enforcing that, but that's what they've put forward and are doing today. And we're also seeing in the places like Texas where the DOT mandates, like this isn't in any law, but they mandate the fact that contractors and engineers use Sioux data for any project that they have. So I'd say that there are very significant strides that have been taken in the industry since that first utility strike. And what was it? The 1980s is what they said. I don't know the
Yeah,
first
19.
one,
Yep.
but yeah,
Yeah, and I think that something that stands out to me was the poor record keeping of the
for
utility lines,
instance,
which I know is something, David, we see all the time with our mapping team being able to go in, utilize the AI conflation engine to aggregate a lot of data together, but then also use visual imagery to say, this scarring here says this isn't actually
yeah,
here, it's over here. Um, Sometimes in the case of this particular story, it can be life and death. Um, so it's quite a big deal to make sure that you know where things are under the ground. Something that I don't think a lot of us think about every
yeah,
day, but definitely, I think the folks that listen to this podcast do. But for those of us
yeah,
newer to the industry, you know, that you don't
yeah.
think about every
I
day.
think though that it's the realm, the new continent of subsurface utilities. It's not new, but it feels new because it's getting more and more headlines today. Because as we expand globally as humans and we create more and more cities, the underground is becoming more and more dense. And even though we'd expect that with technology and standards and SOPs and whatever, we'll see a sort of a decline in the utility strikes. It's only getting worse. And I think that we're kind of at a tipping point where we need to, as an industry, start doing things very, very, very different. And I think this is all over construction, where there needs to be some sort of adoption of data driven technologies. Because what we're not sharing amongst us, what we're not sharing amongst all stakeholders of the project and is kind of siloed in our specific needs for the project is hurting and creating risk for the project and risk for the people, risk to the schedule, risk to the cost, and specifically regarding subsurface utilities, which is the biggest risk of all projects because it's the biggest variable, like it's the biggest unknown. So there's a huge need for that. And hopefully we'll see more companies like ours that are trying to do good in this space and create more and more of that data.
Yeah, no, absolutely. And just from a couple recent conferences that I've been attending as I'm trying to learn more about the industry is, listening to the challenges and the frustrations of the folks that are on these job sites saying, there's not enough people here to do the locates. I can't get them out here. I've put in my ticket, or something took a little longer, so now I have to put in the ticket again. But just not having the people to go out and do what's needed is challenging. So how do we solve that problem with technology? So bigger question than I
Yeah,
think
I don't know if
Chat
don't know
GPT
if I can
can
answer
address.
exactly. Uh, let's see what else
So
do we have here. Um, Okay, here's an interesting question, piggybacking off your last statement. Why is it so hard for utility owners to share their utility data with project stakeholders who are designing projects near their assets? And then to give a bit of context to
Yep.
the question, so we get a lot of feedback for customers or partners in the industry that, okay, I figured out who's the utility owner of that pipeline where I want to excavate, and now I'm reaching out to this utility owner, and maybe they don't respond. Maybe they tell me to wait 90 days and don't contact me in 90 days. And maybe they ask me to get in my car and drive 6 hours to an abandoned warehouse where I need to kind of pick out that hard copy from the forgotten basement in the outskirts of the town that no one's ever heard of. And there's a huge challenge for utility owners to share data. So why does Kathy think that is?
Let's see. Well, she says here there are several reasons why it can be challenging for utility owners to share their utility data with project stakeholders designing a project near their assets. She has 5. So, number 1, data privacy concerns. Utility owners are often bound by privacy regulations that restrict the sharing of sensitive information, such as location data or specific details about their infrastructure. 2, liability concerns. Utility owners may be hesitant to share data if they are concerned about potential liabilities or risks associated with the construction or operation of nearby projects. 3, lack of standardization. There's often a lack of standardization in the way utility data is collected, stored, and shared, which can make it difficult to share information in a way that is useful and meaningful to project stakeholders. 4, limited resources, as we just mentioned. Utility owners may not have the necessary resources or personnel to manage and share their data effectively. 5, communication barriers. Communication between utility owners and project stakeholders can be challenging, especially if there are different languages or technical jargon being used. In conclusion, she says, overall, it is important for utility owners and project stakeholders to work together to establish clear communication channels and protocols for sharing information. This can help to build trust and ensure that all parties are able to access the information they need to design and build safe, efficient projects.
So there are some things there that I understand to some degree, and some of them just seem like excuses. I think the standardization and the utilization of the data, I think, is a bit of an excuse. But there's a lot there which has some truth to it. And you know, when we were at the when we had that joint event with Texas 811, and there was a telco guy there, a telco rep there, who said, "Hey guys, I'm willing to share my data if the rest of you are willing to share it too." And I think that we've kind of there's an industry narrative that we don't want to share as facility owners, as utility owners. We don't want to share our data because we're afraid that the competition is going to know where our pipelines and where our fibers are buried, and then our competitors will know where we want to expand to. But if we're very honest with ourselves, today in 2023, they know. They know where everyone is going. They know where everyone is building assets. And the real question is today, who's fastest? Who's going to be the fastest person to get there? And when we have, and when we're not sharing data, we're slowing everyone down. And especially we're slowing ourselves down because as the utility owners, because also the utility owners, when they want to expand their network, they need to get utility data. And if their colleagues, if their counterparts in the industry aren't sharing the data, so like it's kind of jamming everyone up. And I think we're seeing a shift in that. I think we're seeing more and more utility owners that are kind of, okay, how do I accelerate the construction of my network, and thinking about, okay, so maybe it's time that we start sharing this utility data, which brings us to another challenge that I think that a lot of utility owners don't want to admit this, but they don't have the data. They haven't cataloged it. They haven't made it digital. They haven't made it usable for the designers and the engineers creating these projects. And I think that once there's some sort of mandated or legislative initiative to kind of put that out there, we're going to see a lot of pushback from them, because it's going to put them in some sort of a position where they need to admit the catastrophic state of data storage and data collection that they have. But maybe that will, yeah.
No,
So
it's very true. And so I asked Chat Kathy a follow-up question. I said, how can we navigate around the data privacy concerns for the
yeah,
betterment of the industry? Now, mind you, I'm sitting inside of the same chat. Every time you're asking a question, I'm starting a new Chat GPT,
yeah.
like a new chat within it, so that it's not feeding off of the one prior to it. So it's giving us its fresh perspective each time. But this one I left inside the same chat. And so she actually isn't too far off from your thoughts
Oh,
and opinions as well. Um, yeah, so I'm not going to read the whole thing this time, but she does say one way to address data privacy concerns is to establish clear guidelines and protocols for data sharing. These guidelines should outline what types of data will be shared, how the data will be shared, who will have access to the data, and what safeguards will be in place to protect sensitive information. So I thought that was it. She also said that utility owners can explore the use of, and I'm going to butcher this word, anonymization
yeah.
techniques, such as masking encryption to protect sensitive data while still allowing stakeholders to access the information they need. And then she did also touch on what you did, which was the collaborative efforts to develop industry
Yeah.
standards for data sharing. So,
Another pushback that we've heard a few times is the homeland security argument, which is kind of, we don't want bad
yes,
actors knowing where the utilities are buried, so they can't uh, uh,
poison our
exactly
water
blow
or,
up
yeah,
pipelines or do whatever that the bad actors want to do. Um, and then
right.
one of our supporters commented on this argument, and he said there are hundreds of thousands of utility strikes a year. How many bad actor incidents have we had a year? So when you look just at the pure risk factor of what's more important to deal with right now, it's the fact that we're having accidental utility strikes. The second point is that I think that bad actors, if they really want to poison our water or blow up our pipelines, the data's out there. Like, the data really is out there. Like, if you want to
Yeah,
blow a pipeline up in Texas, go onto the Railroad Commission website, look into their GIS platform, and you'll find the pipeline. You'll find any pipeline that you want in Texas. And it's not like, and there are others like this all across the country, other platforms like this. So I think that there's, in 2023, there's no more excuses for having that one source of truth with all the utility data in it. And it needs to be out there so everyone can use it.
agreed.
What's next?
Okay, what's next?
Um, okay, I have an interesting one here. What are the most effective industry standards for gathering utility data and preventing utility strikes? Let's see if Kathy really knows our industry.
Ooh, let's see. So, to prevent utility strikes, there are several industry standards for gathering utility data that can be effective, including one, call before you dig. Hopefully, we all know about
Yeah.
that one, 811. The standard requires contractors to contact their local one call center before digging to request information about the location of buried utilities. This information can help them avoid hitting underground utilities during construction. 2, utility mapping. Utility mapping involves identifying and mapping the location of underground utilities, including gas lines, water pipes, and electric cables. This information can be used to create detailed maps that contractors can reference to avoid utility strikes. Non-destructive excavation. Non-destructive excavation techniques such as hydrovac excavation use high-pressure water and vacuum technology to safely expose underground utilities without damaging them. This allows contractors to verify the location of utilities before digging. Here's one of our favorites, David. Use of technology. Advanced technology, such as ground-penetrating radar, can be used to detect underground utilities and their location. This can be especially useful in areas where utility maps are incomplete or outdated. This is where I think she's also missing the AI conflation engine of being able to aggregate lots of data together to get these maps. So she's missing that, but we can't be upset with her because her knowledge base is limited to everything input into her system up until 2021.
And the
I
use
think
of
September
imagery
2021.
to verify the records. Yeah.
Exactly. And then 5 is training and education. Training and education programs can help contractors and utility companies to understand the risks associated with utility strikes and how to prevent them. This includes providing training on best practices for excavation, the use of technology, and safe work practices. So
I'm very
those were her 5.
disappointed. Not one mention of Sue.
Yeah.
Not one mention of the quality levels.
No.
No quality level D. Like maybe A was a bit of the hydro vacuum, and maybe GPR and the 4B, but I'd expect like a detailed. These are the quality levels in the industry. This is how we collect utility data. This is what they mean. Very disappointed without Chatty Cathy. Not not
Well, let's give her a little more context. She's only as good as what we put in there. So let's say, what are more detailed ways?
Let's see. Let's see what
And
comes
see
up.
if it finds
Let's see
anything
what
good
comes
for
up.
us. Sure. Here are more ways to gather utility data and prevent utility strikes. Oh, let's see. So she's back to call before you dig. Oh, all she's doing is expanding upon the 5 that she already has. But I'm not seeing anything come up about Sue. So I think we would
Give
have
her
to
a
get a
hint.
little more
Ask her if she
specific.
would include Sue in these methods and techniques. Let's see. And if so, what do you know about Sue?
Okay, let's see. She is thinking. She says, yes, subsurface utility engineering is an important technique and can be used to gather utility data and prevent utility strikes. SUE is a process that involves using various geophysical and surveying techniques to accurately locate and map the location of underground utilities. The data collected through SUE can be used to create detailed maps and 3D models that can be used to plan construction projects and avoid utility strikes. And then she does go on and she lists in detail the quality level A, B, C, D, and goes on to say that she's valuable in preventing utility strikes in combination with other industry standards, such as call before you dig, and then she lists the 5. She's sticking by her 5.
Okay. Okay, we'll take it. So next question. Is it possible to create a national map of subsurface utilities, and how would you do so if so?
She is thinking, blinking. So, oh, she says yes. Yes, it is possible to create a national map of subsurface utilities, and several countries have already done so. Here are some steps that could be taken to create such a map. Conduct a comprehensive survey of all subsurface utilities. This can be done using a variety of methods, including ground penetrating radar, electromagnetic surveys, and vacuum excavation. The survey should include all underground utilities such as gas pipelines, water mains, sewage systems, fiber optic cables, and electric conduits. Collect and compile the data. Once the data is complete, look, she's giving us the step-by-step instructions, but she's making it sound really easy to do.
Yeah, I don't.
Just break down that first one for me, David. If you were to map, let's just say the state of Florida, where I live, using only ground penetrating radar, electromagnetic surveys, and vacuum excavation, how long would that take?
I don't even know how to start assessing that, but I don't think that's an achievable task. But let alone creating like the entire United States. I don't like, especially not with boots on the ground. Like GPR, I don't think GPRs are the solution today, because, and we're even, I think, seeing this like the evidence for that today, right? Because when do we call out the field investigators, the guys who are boots on the ground? The closer we get to construction, because we know that project is actually going to happen, and we're actually interested in making that investment that six-figure, probably six-figure investment, if not bigger, depending on the size of the project, of sending a team into the field. But when we're at the kind of early stages of design, of 2 years, 3 years before that project even starts, we're not spending six figures on someone who's just going to go investigate 1 or 2 miles. It's not going to happen, because when we're at that stage, we want to look at the whole project, which can be, I don't know, 10 square miles or 20 square miles. Like, we want to be able to maybe do some route concept planning. Like, there are a million things that we want to take into account. So we don't even have the opportunity to do that today, because field investigation isn't able to grasp that type of project in such a short period of time and in such a low financial cost. So I did like to answer the question. I doubt we're going to be seeing someone do that manually with boots on the ground anytime soon. So, but nothing in there about AI,
No.
nothing in there about aerial and satellite imagery.
Let's know we've got collect and compile data, verify and update data, checking with public records, creating a GIS database, develop communication and sharing protocol, and then update
I
the
would
map
expect
regularly.
from an intelligence of Chat GPT-4 to be able to come up with a plan of how to do that. But maybe to share with the audience what our devious plan of making that happen is. So we're 4M is on a mission of creating the first national map of subsurface utilities in the United States. And the way we're doing that is, first, we've collected millions and millions of sources and records of subsurface utility data, and we've put them in a AI conflation engine, which is basically able to tell the difference between what are records that you can count on and what are records that are probably you shouldn't be using. So there's that level. And then we have another layer, which is we have access to 60, borderline 70 years of satellite and aerial imagery. And we've developed computer vision algorithms and techniques that are able to scan this imagery and look for what we call visual evidence that indicate towards the existence of buried utilities. So, for example, if we see imagery from 2001 of an excavator with its pipelines near a trench that starts next to a sewage plant and ends at the outskirts of Austin, so we know what's there. And if we see scar marks, or we see valves or manholes, or any other type of visual evidence, we're able to basically say, okay, there's something here. And then what we do is we put these two layers together, the records with the imagery, and basically we're able to verify the records using the imagery. And because we're using millions of records and looking at imagery, so we're able to do this at scale and not just focus on that 1 small mile of a highway or 2 miles of highway. We're able to map out entire states. So, for example, 4M is we've already mapped out the entire state of Texas. We've mapped out California, which I think accounts for about 10% of the United States in total. We've got Florida coming up. We've got New York, possibly Colorado, and probably, I think, 10 states by the end of the year, which will probably be the biggest states in the U.S. So I'm a bit also here.
Or like they might not be the biggest. New York isn't the biggest, but it definitely. If you've ever been to New York City, you know that they're constantly doing work.
Spaghetti bowl of utilities there in downtown Manhattan. Yeah, that's.
It's like spaghetti. It's
exactly,
like spaghetti.
Exactly. So I think like I'm a bit disappointed with Kathy for kind of depicting like a very manual way of creating such a map. Like that's completely unrealistic. So
it really is. I mean, there's no. It would be like trying to, take a lawnmower and mow like when you mow your lawn. And just like mow the entire
I have a follow-up question for her. why hasn't it done before? Maybe she can enlighten us. Why isn't it
Why?
done before?
Oh,
Yeah.
why hasn't it been done before? Well, I already asked her a follow-up question. I asked her about
Okay.
AI and technology, and let me read that first, and then we'll go back. Yes, AI can definitely help in the creation of a national map of subsurface utilities. She lists machine learning, remote sensing, augmented reality, mobile mapping techniques, and cloud computing.
I'm not impressed.
Me either. Me either. But I will say, I mean, it's what a lot of people are seeing that's mainstream right now with Chat GPT and Dolly, which is the one that can do the image. You can request an image. I would like a woman on a unicorn, like the utility unicorn that we work with, Stephanie, flying over an interstate, and it'll just create it for you based upon its algorithms and the data that it's been fed. So, but what David was just describing with the AI conflation engine, it's like that's the real world and what really is going on behind the scenes. Maybe not as sexy as being able to create a woman on a unicorn flying over an interstate, but very sexy probably to the audience that's listening right now.
Maybe.
So,
we have a last question
maybe.
that we often ask our guests, which is who should be the next guest on the Utility Strategy podcast?
Oh, let's see. Okay. Who should be the next guest on the Utility Strategy podcast? Oh, let's see what she says. She's thinking. As an AI language model, I don't have access to information on upcoming events. But she does have some suggestions for potential guests based upon their experience in utility strategy. So she goes on to list industry analysts or consultants, CEOs of successful utility companies, representatives from regulatory agencies, sustainability experts, technology experts who can discuss how innovations such as AI and a list of other things are impacting the industry, and how companies can leverage these technologies to improve efficiency and customer experience. So nobody specific, but she gave us some ideas for folks that we can.
I think we definitely can't count on Chat GPT to solve the challenges of subsurface utilities. I think that's the lesson learned from today.
I think you're right. Key takeaway.
So,
but that was a lot of fun, David. I'm so excited that I was able to join you on the show and to play the part of Chat GPT. I should have tried to do a more robotic voice.
Yeah, maybe for next time. Maybe for the next version of Chat GPT, we'll do a new one. See if they get any smarter.
Perfect. Good. Perfect.
Thanks, Lindsay, and thanks, Chat GPT, for being on the show.
Thank you, David. It was a lot of fun.